Okay, I'm here to teach you about the mole. And the mole is actually what we call a counting unit, kind of like a ream of paper is 500 sheets of paper, or a dozen donuts is 12 donuts. So the value of the mole is 6.02 times 10 to the 23rd. I apologize that 23rd isn't an exponent, but it's 10 to the 23rd. So like I said, the mole is a counting unit. It's also referred to as Avogadro's number. That handsome fellow on the right there is Amedeo Avogadro, the scientist that studied the quantities of gases, and he discovered that no matter what gas it is, there's always going to be the same number of molecules present. So once again, the mole is a value of 6.02 times 10 to the 23rd, or 602 billion trillion. I'll stick with the scientific notation. So, like I said, 6.02 times 10 to the 23rd, you're going to hear that number a million times, have it memorized. So we say a mole contains 6.02 times 10 to the 23rd particles. So your particles could be atoms, your particles could be molecules. So a couple examples here. An atom we're going to use when we have just one single element all by itself. So the example I give you is carbon. If we're using molecules, we're talking about a combination of elements. So H2O, NaCl, we would use molecules in those cases. But molecules and atoms are both examples of particles. So these are really just going to be conversion problems. Like we did at the beginning of the year, you all did a fantastic job on that. So the first example I'm going to show you is to convert 3.6 moles of calcium to atoms. Now I'm using atoms because I'm just talking about calcium, one single element all by itself. So just like the conversions you've done in the past, you start with the number you've been given, so 3.6 moles in this case. MOL is our abbreviation for mole. So take what's given, put it over 1. We're going to set up our conversion factor. So mole will go on the bottom because we're trying to cancel out moles. And we're converting to atoms, so atoms will go on top. And then we have to fill in our numbers here. So here's my conversion factor. Wherever the mole is in your conversion factor, always gets a 1. In front of atoms, we put that special number, 6.02 times 10 to the 23rd. I apologize for my handwriting, but you can see what that says. So my conversion's all set up. We're going to cancel out our moles so that we're left with atoms, which is great because that's what the problem is asking you to solve. So we're going to multiply across 3.6 times 6.02 times 10 to the 23rd. We may need to do a review of how to put the times 10 to the 23rd into your calculator. So if your calculator is similar to mine, how you would do this is 6.02 double E 23. So check out your calculator. If you have any questions about how to put it in your calculator, let me know. So when you do your calculation, I get 2.1672 times 10 to the 24th. But we need to look at sig figs. So how many sig figs? 3.6. 3.6 has 2 sig figs, so I need to change my answer so that it only has 2 sig figs. So my final answer, 2.2, so we had to round up there, times 10 to the 24th. And we do have to label it, so we have atoms. And very important that you also tell me, what do I have atoms of? What element am I talking about? So in this case, I have atoms of calcium. Example number 1, complete. Example number 2, we're going to do it a little bit backwards of what we just did. So this time we are starting out with 3.40 times 10 to the 24th molecules of sodium hydroxide. Now the reason I have molecules instead of atoms is because I'm talking about a compound, not just a single element here. So you know what I want to do first is come up with the formula for sodium hydroxide. So sodium is Na. hydroxide is one of our polyatomic ions, so OH. Na is a +1. OH is a -1. We don't need any subscripts. We're good to go. So setting up the problem, I take what's given, 3.40 times 10 to the 24th molecules. I'm going to abbreviate molecules MOLC. So take what's given, and we have NaOH. You want to include that. Put it over 1. So because I have molecules on top, I need molecules on the bottom. And we're converting that to moles, so MOL. And remember from my previous example, wherever I have mole, doesn't matter if it's top or bottom, always gets a 1. Molecules is our new fancy number, 6.02 times 10 to the 23rd. So the problem is all set up. Let's cancel out the molecules, cancel out the molecules. We are going to divide this time. So we have 3.40 times 10 to the 24th divided by 6.02 times 10 to the 23rd. So when I put that in my calculator, I get 5.6478. But looking at how it was given to me in the problem, I have 3 significant figures. When you're looking at 3 significant figures, you don't need to worry about the times 10 to the 24th. You just have to look at that base unit, which is the 3.40. So 3 sig figs. So my answer is 3 sig figs. We were going to label it. So we have moles. And what do we have moles of? Sodium hydroxide. All right, problem number 2 done. Hopefully you are all set to do your conversions now.